A truth table is a tool that we use to describe how the circuit's output depends on the logic at the output. So let's draw a logic gate, a generic logic gate. Let's say just generically, it's just a rectangle. We don't know if it's an AND gate or a NOT. We don't know what's in here, but it's going to have some inputs, and we'll call those inputs input A and input B. And the output is going to be, we're just going to call it X. So this is just a logic gate. And we say, how many inputs are there? These are the inputs. And there are 2 in this example, and this is the output. So a truth table is just a tool that says, what is the output given the inputs that we have? So a truth table says, what is the output? Given the inputs. Well, and we organize a truth table in the following manner. We say, what is the output X? Given the inputs A and B. Well, what can A and B be? Well, we learned about binary, so it can be any binary value. So A could be the binary value 0. B could be the binary value 0. A could be the binary value 0 and B could be a 1. Or A could be a 1 and B could be a 0. Or A could be a 1 and B could be a 1. And the output is very much dependent on what is the logic gate. Okay, so in this case, we don't know what the output is, but the truth table would show what it is depending on the gate. So truth table, I'm just writing in here, would show output depending on what the gate is. Okay, and I'm not going to put values in for ones and zeros there because we don't know what the gate is in this case. So that's all, that's what a truth table is. So let's do another example of a 3-input truth table. For a 3-input truth table, let's say the gate looks like this. We don't know what it is. It's got an output X and it's got 3 inputs. One, it's got the first input, interesting, I'm having trouble drawing on my screen. There we go. 3 inputs, A, B, and C. So that's what it looks like. So the inputs are, there's 3 of them. The output, there's just 1. And draw the truth table. If I were to draw this truth table, it would have inputs A, B, C, and it would have output X. And the values could be 0, 0, 0, 0, 0, 1, etc., all the way down to 1, 1, 1. So I'm going to show you a trick for filling in truth tables. There is only one way of filling in truth tables. What you have to do is you have to know how many combinations there are for any truth table. It was a simple matter over here. We know that if there are 2 inputs, there must be 4 combinations of inputs. because each one could be a 1 or a 0. So with a little bit of thought, even if you don't know that on the top of your head, you know, you could figure out that there are 4 combinations of 1s and 0s that could go into that. If I gave you a little bit of time to think about the 3-input truth table, you would figure out that there are 8 combinations. There are 8 combinations of 1s and 0s that could go into this truth table. So in general, in a 2-input truth table, there are 4 entries. I'm going to write that over here. In a 2-input, there are 4 different combinations. In a 3-input, there are 8 entries. In a 4-input truth table, so A, B, C, and D, there would be 16 entries. In an n-input truth table, there are 2 to the power of n entries. So if I ask you how many entries are needed for, say, 1, 2, 3, 4, 5. So if I say, for example, 5 input, then it would be 2 to the power of 5, which is equal 32 entries or rows on that truth table. Now, how do you draw something as big as 32 rows? Or for example, let's see, in this example, this is a 3-input truth table. So it's pretty big. It's going to have 8 rows. Do I just think about each of those combinations separately? Like, I think there'll be a 0, 0, 0. And I think there'll be a 1, 1, 1. But how do you keep track of all of the combinations in between? So here's how you do it. You remember that there's going to be 8 rows. And what you do, I'm just fumbling with my controls. So you remember that there's going to be 8 different rows. And what you do is you take your first input and you give it 0s for half of the truth table and 1s for the other half. Then you look at your next input and you give it 0s for half of the truth table and 1s for half. Sorry, for half of the next half of the truth table. And then 0s and 1s. And then you split it again. And the last one, you give 0, 1, 0, 1, 0, 1, 0, 1. So you keep splitting it like that. And that's how you draw your truth table. Now, depending on the circuit, you would have 0s or 1s here. So output depends on the circuit. And I don't know what the circuit is here because I drew it as a big sort of a black box with a question mark in it. So that's how you make truth tables.